All right, let's finish off 3.3, looking at some word problems with unlike fractions. So Susan is designing an office complex. She needs 2/5 of an acre for buildings, 1/3 of an acre for driveways and parking, and 1/6 of an acre for walks and landscaping. So she wants to know how much land she's going to need to buy for this office complex. So we're looking for a total amount of this land, which means we're adding it. So we have a 2/5 plus a 1/3 plus 1/6. So we need to find a common denominator then for all three of those denominators. I'll do that up above here. So I've got 5, 3, and 6. Let's use our division method, or go ahead and do the tree if you prefer the tree. And so here I can see that 3 and 6 are both divisible by 3. So 5 comes along for the ride. I get a 1 and a 2. And my numbers are already all prime. So that was easy. So least common denominator then is 3 times 5 times 1, won't change it, times 2. So that's 15 times 2, which is 30. So my LCD here is going to be 30. So I'm going to write each of these fractions then as a number over 30. Okay, so to get from the 5 to the 36, I had to multiply by 6. So we're going to multiply by 6 on top to get 12. To get from 3 to 30, we have to multiply by 10. So we get a 10 on top. And to get from 6 to 30, we have to multiply by what? Here we have to multiply by 5. And so that's going to leave us with 5 over 30. So let's rewrite our expression, I guess, here. 2/5 is the same as 12 over 30. Plus 1/3 we said is the same as 10 over 30. And 1/6 we said is the same as 5 over 30. So now we have a common denominator here. So now we can add our numerators. So 12 plus 10 plus 5. And I'm just going to cheat and use my calculator to get 27. I guess it's not really cheating. Over 30. Okay, now we want to simplify that as much as we can. And I can see right away, I see that I can divide both these numbers by 3. So I'm going to go ahead and do that. Remember, you could always figure out your greatest common factor to figure out what to divide by 2. But I just happen to notice these are both divisible by 3. So what does that give us? 27 divided by 3 gives us 9. 30 divided by 3 gives us 10. I know 9 and 10 don't share any prime factors, so that means this is as simple as it could be. So she needs 9/10 of an acre. Okay, pause the video and see if you can do the next one on your own. Okay, let's try this question together. So Max is making 3 different recipes. He needs 3/8, 1/2, and 3/4 of a gallon of tomato sauce. And he wants to know how many gallons he needs altogether. Okay, so we want to add these 3 together. So 3/8 plus 1/2 plus 3/4. So we're going to be looking for a common denominator here. So we're looking for a common denominator of 8, 2, and 4. And hang on a sec. 8 is a multiple of 2, and 8 is also a multiple of 4. So my least common multiple here is going to be 8. Now I could also do the tree method or the division method, and I'll end up with the same answer there. So 3/8, so 3/8 is easy. That's already over 8. Then we've got 1/2. So let's figure out what it is over 8. And 3/4. So what is it over 8? So 1/2. So the 2 we had to multiply by 4 to get to 8. So we're going to end up with 4 over 8. And then that next fraction here, we have to go from 4 to 8. So we have to multiply by what? By 2. And so there we're going to get 6 over 8. So let's rewrite this expression here. 3/8 is the same thing as, oh wait, 3/8, because the denominator didn't change. And then 1/2 is 4/8. And we said 3/4 is the same thing as 6/8. So now in our answer, we're going to add up those numerators. So 3 plus 4 plus 6. So that's going to be 7 plus 6, which is 13. Over, denominator stays the same, so 8. So we end up with 13/8, and that is a fine answer, or we could convert that to a mixed number. Let's convert it to a mixed number. So 13 divided by 8, we can do 1 time, and we're going to end up with a remainder of 5. So this would be 1 5/8. And for some reason, I can visualize that a bit more, so I think I'll use that. So Max needs 1 5/8 of a gallon of tomato sauce. And I just finished canning a bunch of tomato sauce, and I think I have plenty of tomatoes. So I think I have plenty of tomatoes for Max to use. All right, moving on. Let's take a look at this next one. We have a concrete walk, which requires 3/4 of a cubic yard of concrete. If we mix 8/9 of a cubic yard, so almost a full cubic yard, will we have enough concrete left over to do a project that uses 1/6 of a cubic yard? Okay, there's a couple ways we could tackle this. We know we want to make our concrete walk. So let's do that first. We have 8/9 of a yard cubed total of concrete. So let's subtract the 3/4 of a yard we're going to use. Okay, so we need an LCD there. And so 9 and 4, I think we'll do the division method here. There are no common factors, so I'm going to pull out a 3. And there's no common factors again, I'll pull out a 2. And so my LCD is 3 times 2 times 3 times 2, which is 36. Okay, so I need equivalent fractions here for 8/9 and 3/4 that are over 36. So 9, I had to multiply by 4. So 8 times 4 gives me 32. And 4, I had to multiply by 9 to get to 36. So 3 times 9 gives me 27. So this would be the same thing then as 32/36 minus 27/36. And that is 32 minus 27 gives me 5. So 5/36. So let's call this concrete after our first project, which was the walk. So concrete after we've poured the walk. Okay, now we have 5/36 of cubic yard of concrete left over, and we want to do a project that uses 1/6 of a cubic yard. So let's figure out what 1/6 is then in terms of 36. So 1/6, so let's say next project uses 1/6, which is what over 36? So we're going to be multiplying by 6 this time, and we get 6/36. So we have 5/36 of concrete, but we need 6/36 of concrete. So therefore we could say there won't be enough concrete left. Okay, and last question. So take a read through this question, give the video a pause, and see if you can set up the expression that we would use to try to figure this out. Okay, so hopefully you had a chance to look this through. Ricardo is cutting 3 strips from a 1-inch piece of metal. Okay, so he's got this piece of metal and he cuts 3 strips off of it. Okay, how much remains after the cuts? So we want to know how much is left here. So the full thing here is 1 inch, and his pieces here are 3/16 of an inch. So we want to know how much remains after the cuts. Okay, let's think about this. So we want that green amount. So we started with 1 inch, and then we subtracted 3 pieces. Each of them were 3/16 inch. So this is going to involve some subtraction. I'm just going to rewrite that. This is going to involve some subtraction and also some multiplication. Okay, so let's start by getting rid of that multiplication. Remember that 3, it's a whole number, so it's really over 1. So we've got 1 minus, and then we do top times top over bottom times bottom to get 9/16. All right, well, now we need a common denominator here. This 1 really has a denominator of 1. So our common denominator here would be 16. In other words, we want to express that whole number, that 1, as some number over 16. And if we think about that, 1 over 1 is some number over 16. Well, we had to multiply by 16. So that's what we want to multiply by on top. And that makes sense, right? Because if you had 16 pieces of something and you have all 16 pieces, that means you have one whole thing. So we have 16/16 minus 9/16. Now we have like fractions, so we can subtract them. 16 minus 9 gives me 7, so I have 7/16. So we can say 7/16 of an inch of the metal remains. And that's it for section 3.3.